what are the key evaluation criteria for waterproofing membranes, which are essentially liquid applied polyurethane hybrids and polyurea. First of all is water absorption. So if the film will absorb water, it will start degrading the polymer. And once it starts degrading the polymer, then it will lead to a failure. So obviously, a waterproofing material must have the lowest possible water absorption. No, and then and normally water absorption is reported in many ways. Some people talk about 7 days. I've even seen people talk about 24 hours results or a 30-day result. That's really not the right way to go evaluate it. How we evaluate is a saturation water absorption, which means you take a film of the product, put it in water, and let it absorb whatever water it wants. And once it stops absorbing the water, it's saturated. Now it can no more absorb any water. So that's the key no criteria which we look at. So for any coating, we are looking at where it is going to be in immersion. So such as your water tank, no overhead tanks or a swimming pool, similar application, or even a constant water exposure like a podium where you have vegetation or grass which every day it is watered. That is also coming broadly into the same criteria. There we are looking for a long-term weight gain of not more than 1%. And the only product which meets this requirement is a cross-linked polyurethane. It's still elastic, but it is essentially a cross-linked polyurethane. If you want only a short-term exposure application, no, like a roofing, then we can look at even products with a less than 3% saturation weight gain, in which you have several options of polyureas, hybrids, 1K polyurethanes, etc. So this kind of differentiates is how resistant to water absorption are these products. So this is something, so a coating must have a crack spanning capacity, and it should have a sufficient crack spanning capacity in relation to what is your anticipated cracking of that structure. Now, when people think of crack spanning, immediately they think, okay, if something has got 300% elongation, 400% elongation, it should have a good crack spanning capacity. That's not true. Actually, crack spanning is a complex function it depends both on elongation and the tensile strength, right? So I'll give you some examples before. If you have, say, for instance, a cross-linked polyurethane or an elastic polyurea, or even a 1K membrane, 1K has even lower. So, say the cross-linked polyurethane would have no elongation of about 100%. The elastic polyurea would have 400%, but they both end up within the same crack spanning capacity band of 2.5 to 3 mm because the polyurethane in addition has excellent tensile strength, right? If you have a 1K, that's a single component polyurethane, although the elongation at break is around 400%, still the crack spanning capacity is less than 2 mm. So it's not only the elongation which is important, this tensile also emerges. One new novel concept is the combination system in which you have a flexible base coat and then you have a harder polyurethane top coat. There you can actually jump up the crack spanning capacity to 10 mm or more. Okay, so what else do we need? We need tensile strength because tensile strength is a measure of your toughness of the polymer. The film needs to be very tough because normally, although waterproofing is installed at the fag end of the building construction, but still there are lots of parallel trades which are working, your HVAC, electrical, finishing, all that. So all those crews are roaming around, no walking over the waterproofing and dragging their equipment. So if the film is weak, it will get damaged and then subsequently it will leak once it's put in service. So you need a film which should be tough and resistant to damage. In fact, now we have waterproofing membranes which are so resistant to damage that you can actually put them on the foundation raft and then you can actually erect all the rebar and all the you can drag reinforcing bar over it. It doesn't get damaged. So uh, the technology has changed quite a bit. So you have very tough films. Now, as a reference point, if we see a single component polyurethane, it has a hardness of only 8 to 10 SHORD, tensile strength of 2 to 4 MPa, which is really on the low side. You can very easily damage it. The hybrid polyurea hardness is 20 to 40, still okay. Tensile 10 to 15, not bad. And the polyurea is 40 to 45 hardness, 20 to 25 tensile. Again, these are tough films. And the toughest is the cross-linked polyurethane, which is a 65 to 70 SHORD hardness and a 15 to 25 MPa tensile. So the film must be tough. Otherwise, it will get damaged, as we've seen in the case of 1K polyurethanes. Uh, the film has to be alkali resistant. Why? Because we know concrete itself is very highly alkaline. It has a pH of ranging between 12.5 to 13.5. So if the film is not resistant to no alkalis, then it gets chemically attacked by the concrete alkaline nature, and it will lead to disbonding or blistering and degradation of the film itself. So alkali resistance is very important, never spoken about in the waterproofing industry. This is again a very important thing. So let's say, how do we test the alkali resistance? We take the film, we put it in saturated sodium hydroxide for 30 days, and then we see the weight gain. 1K polyurethane, the film is completely destroyed. It shows that it's very mildly resistant only. So this is the surprising part. The hybrid polyurea or the pure polyurea, the weight gain is between 1.5 to 2%, which is kind of okay, but still it is not of the highest order. And you compare it to the cross-linked polyurethane, your weight gain is typically 0.3% no, in 30 days immersed in saturated sodium hydroxide. So again, very important property, we need to evaluate this. Coming to the addition, if the membrane disbonds from the surface, it will allow ingress of water from adjacent areas. Which in effect, you might as have not put any no membrane, because everything will flow under the membrane and going to the concrete, which is essentially what we call a failure. Well-performing polyurethane hybrids and polyureas have an addition to the surface, which is typically more the tensile strength than the of the concrete. So if you do a pull-off addition test, then your break should take place within the matrix of the concrete and not at the interface. So that's the ideal criteria. Like we see the picture on the right, we have done a dolly test, and the dolly has come off, and all the concrete below that has broken, and the coating has remained firmly adhered to the dolly. Right? So there are 2-3 factors which are responsible for this. One is primer. The primer plays a key role in proper adhesion. This is also very important when we are doing retrofitting and renovation, because in existing homes or office buildings, there could be lots of existing type of waterproofings, tiles, and even your membranes, bitumen, this, that, and the other. And a lot of times the customer is not interested in removing all of that because that's a major exercise. So they are keen on applying a liquid applied membrane on top of the existing waterproofing. In this case, the primer plays a very critical role on how well the coating bonds to those compromised surfaces. Then another factor is that the very fast setting polyurea coatings do not allow wetting of the substrate, because they are in 2 to 3 seconds they are gelling. So there is not enough contact with the surface, and they don't wet the surface properly. So they end up with a iffy addition to the surface unless you have done a very thorough surface prep. Again, UV resistance. The formulations of all these products are very different. Say, for instance, a lot of products are polyether polyol based. Even the polyureas are polyethylamine based, right? So that's the basic chemistry, the polyurethane. And polyethers will quickly break down by ultraviolet and sunlight. So you can't really keep them open for any significant period because they do not have the ultraviolet resistance to sunlight. On the other hand, we have polyesters, especially saturated bio-based polyesters, which has outstanding resistance to UV because their polymer doesn't break down with the ultraviolet light. They don't even require a cover, so you can actually save some money in terms of additional protective cover on top of the waterproofing. And then finally, one category of the top coat is the aliphatic polyurethane, which not only prevents UV degradation, but in lighter shades, they have a very high solar refractive index. We have in fact measured that between uncoated and a coated the surface, the difference in surface temperature in peak summers is as high as 14 centigrade. So you are saving a lot of energy in the whole building. And in fact, we can avoid the heat islands. Then application is very critical. So the simplest things to apply are the polyurethanes, and there are certain slow setting hybrids, which are simply applied by a paint roller. All you do is you mix the two components with a drill, pour it onto the surface, and with a paint roller, you apply it in either one or two coats. So there is very minimal skills required. Uh, and one very important thing is here that the wastage is zero because there is no overspray. Spray applied products require complicated machinery, which is fine. As long as the crew is highly experienced, they have very good equipment, maintenance, how to, keep. So whatever I've seen, hundreds of these 2K equipment, it's a very rare case that some crew knows how to properly use and maintain that equipment. A lot of times they are mismetering, which means either the component A or the component B is being applied in excess. It's just, or there's improper mixing between the two components. So if you decide to go for a spray applied product, be sure the applicator is very, very competent. Don't give it to somebody who's got inexperienced crew because these equipment are not very forgiving in terms of no shortcuts in maintenance. Finally, we come to the final slide. Uh, so what we believe, of course, this is our own product, but still, what we believe is the current state of the art is the combination system, wherein first you have a roller applied damp tolerant polyurethane primer. This actually reacts with the surface moisture and cures it, hardens it. And then it also bonds very well on various kinds of substrates, not only blast clean concrete or water jetted concrete, but even on tiles, existing membranes, your EPDMs, your all kinds of existing waterproofing. So again, it starts off with a very good bond. The base coat is a very elastic product with low tensile because we want it to stretch easily and prevent the stresses of the cracks and the substrate from reaching the top coat. The top coat is, of course, a cross-linked polyurethane, which is very, very tough. 65 SHORD hardness, 1500 newtons tear is almost impossible to damage. It's extremely tough. It has very low water absorption and all of those properties, what we are looking for a top coat. And this system together has a crack spanning capacity of 8 mm plus, between 8 and 10 mm. And then finally, if you want, you can apply aliphatic top coat at a very thin, say 300 microns, to prevent further UV degradation or to reflect off the incoming solar radiation. So this is kind of the combination which is now considered state of the art, the best practice in the industry now. and a lot of the customers, including the major builders and all that, have switched over to this kind of a product.